Morning, dear students. This session we'll talk about compatibility equations for two-dimensional problems. Okay, so how you generate compatibility equations. See, in general, why you need compatibility equations? Okay, if any problem cannot be solved using equilibrium equations alone, you need to take the help of compatibility equations. For example, last session we have derived equilibrium equations which are dou sigma x, okay, dou sigma x by dou x plus dou tau xy by dou y plus x is equal to 0, dou sigma y by dou y plus dou tau xy by dou x plus y is equal to 0. So these are the two equilibrium equations for a two-dimensional problem. So the unknowns here are just listing the unknowns. Sigma x is unknown, sigma y is unknown, tau xy is unknown. So you have three unknowns, whereas your equations are only two. So you need one compatibility equation. Okay. So what is that one compatibility equation that you have to use it here? Okay. So in general, compatibility equations are the relations between the displacements or strains. Okay. So now consider the strain displacement relations. Basic strain displacement relations I am going to consider. Okay, what are they? Strain in x is equal to dou u by dou x. They're all in differential form. So I just try to write in xy plane only. So let epsilon y is dou v by dou y. Okay. The shear strain gamma xy is equal to dou u by dou y plus dou v by dou x. So these are the strain displacement relations. So we need to form one compatibility condition or compatibility equation from these three relations. Okay, so now consider epsilon x is equal to dou u by dou x. Okay, you partially derivate this, partially derivate with respect to y. Okay, which means dou by dou y of epsilon x. So dou by dou y of what is epsilon x? It is dou u by dou x, which means dou square u by dou y dou x. Okay. Now again you partially derivate this. Okay. So with respect to y again. Okay. Again the same. So which means dou by dou y of dou epsilon x by dou y we have left hand side. The right hand side dou by dou y of dou square u by dou y dou x. So what you get finally is dou square epsilon x by dou y square left hand side, dou cube u by dou y square dou x. Okay, so let us name this as 1. Yeah, now take the second normal strain is in y direction, v by y. Okay, partially derivate this with respect to x, which means dou by dou x of epsilon y, which is equal to dou by dou x of dou v by dou. So what do you get here? Dou epsilon y by dou x is equal to this left hand side. Dou square v by dou x dou y. Again, you partially derivate with respect to x. Okay, so which means dou by dou x of dou epsilon y by x is equal to dou by dou x of this dou square v by dou x dou y. So now what you get? Left hand side dou square epsilon y by dou x square is equal to right hand side dou cube v by dou x is equal to 5. Let us call this as number 2. Yeah, now let us consider the shear strain gamma xy is equal to u by y plus dou v by dou x. Now you partially derivate this with respect to x first, which means left hand side dou gamma xy by dou x. So dou by dou x of dou u by y v by x. So what do you get? Dou square dou into dou square u by dou y dou x plus dou square v by dou x into dou x dou x. So this is expression that you get if you partially derive this shear strain with respect to x. Now you partially derive this above expression with respect to y now. Okay, so which means dou by dou y of this dou gamma xy by dou x. Okay, so which is equal to dou by dou y of this one dou square u by dou x dou y plus dou square v by dou x square. Okay, right. So let us see what we get. Left hand side dou square gamma xy by dou x dou y is equal to dou into dou square dou cube u by dou x dou y into dou y square plus dou into dou square dou cube v by dou y dou x square. Okay, so this is what you have got. So what is this term? Let us see from linear relations. So what is that one expression you see, dou square epsilon by dou y square is equal to dou cube u by dou y square dou x. That is what we got here. So which means you can replace this with dou square epsilon x by dou y square plus this one. If you see second equation that we derived here, see dou cube v by dou x square dou y can be written as dou square epsilon y by square dou square epsilon y by dou x square. So this is the compatibility relation dou square epsilon x by dou y square plus dou square epsilon y by dou x square is equal to dou square gamma x by dou x dou y. This is the compatibility equation in xy plane. Okay, so similarly, you can derive two planes also like y, z, zx. So when you are solving a three-dimensional problem, okay, so you can generate three compatibility equations. Okay, and the three equilibrium equations are already available. Okay, so which means you can solve six unknowns. Okay, which is a three-dimensional problem. Six unknowns are sigma x, sigma y, sigma z, gamma xy, yz, and zx. So these are the six unknowns in a three-dimensional problem. Okay, so this is how a detailed way of now deriving the compatibility equation for a two-dimensional problem, which is in X, right? Okay, yeah, thank you. We'll see you in the next session.